Hello everyone. At the end of this video, you will understand what the Maclaurin series is and how to derive the Maclaurin's expansion. If the nth derivative of some function fx exists at x equals 0 for all n, the function fx can be written as fx equals f naught plus f dash naught x plus f double dash naught divided by 2 factorial x squared plus f triple dash naught divided by 3 factorial x cubed, and that goes on all the way up to whatever value you want to expand up to. So here I have considered it as the r derivative of fx at x equals 0 divided by r factorial x to the power r. So you can keep on going all the way endlessly since this is an endless polynomial. Now let us consider that this particular condition has been met. That means that fx can be written as a naught plus a1x plus a2x squared plus a3x cubed plus a4x to the power 4 plus, and that keeps on going until ar xr plus, and then you can still continue this endlessly, and the longer the expansion, the more accurately you're going to represent the original function using your polynomial. So let's say that this function can be expressed like this. Now let us consider f naught, which means setting all x values, terms containing x to 0. So this entire section becomes equal to 0, leaving us with just a naught, which means that a naught is equal to f naught. Now let's consider the first derivative of fx. F dash x is going to be equal to a1 plus 2a2x plus 3a3 x squared plus 4a4 x cubed plus the rar xr minus 1, and that also can keep on going. And when you take f dash naught, setting all x terms to 0, this entire section becomes equal to 0, leaving us with just a1, which means that a1 is equal to f dash naught. Now just consider the second derivative. So that's going to be f double dash x, which is going to be equal to 2a2 plus 6a3 x plus 12a4 x squared plus keeps going to r minus 1 ar x r minus 2, and that can still keep on going. Then again do the same thing, set x equals 0, and we get f double dash naught being equal to, so once again this entire section containing x terms becomes equal to 0, so that gets eliminated, leaving us with just 2a2, and that means a2 is equal to f double dash naught divided by 2. Then just to see how the pattern unfolds, is just do another get another derivative. So f triple dash x is going to be equal to 6a3 plus 24a4 x plus minus 1, r minus 2, ar xr minus 3 to the power 8 r minus 3 plus, and that also can keep on going. And if you set x to 0 in this case, f triple dash naught is equal, once again this section containing x terms becomes equal to 0, and we are left with 6a3, and therefore a3 is equal to f triple dash naught divided by 6. Now let us consider these coefficients. We want to identify a pattern in these coefficients. So this can be written as naught divided by 0 factorial, and this is the coefficient of x to the power 0, right? Since it is the constant term. And this can be written as f first derivative naught divided by 1 factorial, which is 1 again, and this is the coefficient of x to the power 1. And a2 can be written as f second derivative is equal to 0 and 2 factorial, which is equal to 2, and this is also the coefficient of x squared. And if you look at this, finally we see that this can be written as the third derivative in x equals 0 and 3 factorial, which is equal to 6, and that gives us x, and this is basically the coefficient of x to the power 3, x cubed. And if you consider f4 also likewise, you will see that this will be coming in the format fourth derivative when x equals 0 divided by 4 factorial, and this is going to be the coefficient of x to the power 4. Now I want you to see this important pattern here. This is 0, this is 0, this is 0. When this is 1, first derivative, this is 1 factorial and the coefficient of x to the power 1. When it's a second derivative, it's 2 factorial over here, and here it's x squared. Here when it's third derivative, it's 3 factorial and it's x to the power 3. And likewise, same pattern keeps on going. So this is an important result. And using that, we can write an expression for the Maclaurin's expansion. So fx is going to be equal to f naught plus f dash naught x plus f double dash naught divided by 2 factorial x squared plus f triple dash naught divided by 3 factorial x cubed, and that keeps on going up till f, r derivative basically, naught divided by r factorial x to the power r, and this is basically n plus polynomial. So this is the Maclaurin's expansion, and it is a very important result, a very important formula in mathematics that is used in a vast area of applications. I hope you understand how we came to this result and understood how the Maclaurin series works. If you understood this result, please subscribe and like this video. Thank you.